Hello, my name is Artyom Sokolov, and I'm Associate Professor from Odessa National Polytechnic University. Let me present to your attention a paper entitled as Prerequisites for Developing a Methodology for Estimating and Increasing Cryptographic Strengths based on Many-Variable Logic Functions, prepared by me, as well as Nadia Kazakova from Odessa State Environmental University, and PhD students Lydia Kuzmenko from Institute of Telecommunications and Global Information Space, and Maria Magomedova from Boris Grinchenko Kiev University. One of the most important components of modern information security system is the cryptographic subsystem, which solves the problem of ensuring the integrity, confidentiality and authentication of transmitted and stored information. In this case, the main component of the cryptographic subsystem is the block symmetric cipher used for cryptographic transformation of large amounts of data. Block symmetric ciphers in many countries are standardized and are used to protect information in the specialized information systems, which is critical for national security. In particular, in Ukraine, the Kalina crypto algorithm is described by the DSTU 7624 standard. These circumstances make the task of estimation and improving the cryptographic quality of these algorithms especially urgent. The purpose of this paper is to research the prerequisites for creating a methodology for estimation and increasing the cryptographic strengths based on the mathematical apparatus of many-variable logic functions. Currently, many approaches have been created to estimate the cryptographic quality, in particular based on the analysis of stochastic properties of output sequences of cryptographic algorithms, in which stochastic quality tests can be used. There is also an approach for research of the degree of implementation of the principles of diffusion and confusion in the cryptographic algorithm based on the research of its reduced copies. But the conventional methodology for quality estimation of constructions of cryptographic algorithms includes their representation in the form of component Boolean functions with further research of their cryptographic quality. After representing a cryptographic construct using Boolean functions, a set of cryptographic quality criteria is applied to them. Today, these criteria for cryptographic quality include the following: algebraic degree of nonlinearity, which characterizes the degree of algebraic complexity of the output of a Boolean function with respect to its input variables; nonlinearity distance, which characterizes the degree of distancing of a Boolean function from the set of Boolean functions that are considered as linear; correlation relationship between the output and the input of the cryptographic construction, which is determined by the statistical dependence of the output of the cryptographic construction on its input; error propagation criterion, which characterizes the ability of a cryptographic construction to propagate minor changes in the input text or key element to the entire cipher text, as well as a linear redundancy of component Boolean functions. Nevertheless, the cryptanalyst is not constrained in the chosen mathematical apparatus, with the help of which the representation of the constructions of the cryptographic algorithm is carried out with a subsequent attack. In addition to the mathematical apparatus of Boolean functions used in the construction of cryptographic algorithms, the representation using 4 functions as well as using 16 functions can be used for almost all modern ciphers. At the same time, the developers of cryptographic algorithms usually do not consider these possible representations and do not research their cryptographic quality. This circumstance determines the need to build, develop, and generalize the criteria of cryptographic quality and the practical aspects of their use for the functions of many-body logic. On the other hand, quantum computers are developing dynamically, which already today allows us to speak about the formation of post-quantum cryptographic methods that will be relevant when quantum computers will develop and quantum attacks will be carried out with their help. Note that the key of the modern symmetric cryptographic algorithm is a pseudo-random sequence. Thus, with a sufficiently large key length, it is required to use a brute force attack or use of any structural vulnerability to attack the cryptographic algorithm, in contrast to the use of algorithmic attacks, for example using Shor's algorithm, which can be used to break asymmetric cryptographic algorithms. This fact makes it especially urgent in the conditions of post-quantum cryptography to research in detail and improve the structure of cryptographic algorithms for any of their representations, especially with the help of functions of many-body logic. Thus, today there is an objective contradiction between the developed methods of attacks on cryptographic algorithm with the possible representation of their structures by functions of many-body logic, while simultaneously developing promising methods of attacks using quantum computers and the actual absence of a comprehensive mathematical apparatus designed to estimate the cryptographic quality of component functions of many-body logic and methods for synthesis of cryptographic structures at a high quality in terms of many-body logic functions. A solution to this contradiction can be obtained by developing a methodology for estimation and increasing the cryptographic strength based on functions of many-body logic. The presented methodology for estimation of the cryptographic quality is based on the following criteria for the cryptographic quality of many-body logic functions in conjunction with the corresponding indicators of cryptographic quality: relative algebraic degree of nonlinearity, relative nonlinearity, maximum and integral deviations from the criterion of independence of the output of many-body logic function from its input variables, maximum and integral deviations from the SAC. Let us introduce the scheme of performed research to ensure the development of the methodology for estimating and increasing cryptographic strength based on many-body logic functions. Step 1. As a basis for creating a methodology for estimating and increasing the cryptographic strength of ciphers based on the functions of many-body logic, a basic method of representing cryptographic structures using component functions of many-body logic is created. Step 2. The criteria of cryptographic quality of functions of many-body logic are defined. Namely, in order to determine the criterion of algebraic degrees of nonlinearity of functions of many-body logic, methods for their representation in algebraic normal form have been created. Based on the introduced concept of imbalance of functions of many-body logic, a criterion of nonlinearity of functions of many-body logic in the time and spectral domain is introduced. Based on the concept of imbalance of functions of many-body logic and the mathematical apparatus of derivatives of functions of many-body logic on the basis of which the error propagation criterion and strict avalanche criterion for functions of many-body logic are introduced. Based on the concept of imbalance of many-body logic functions and mathematical apparatus of subfunctions of many-body logic functions, the criterion of correlation independence of the output of many-body logic function from its input variables is introduced. Step 3. Based on the proposed criteria of cryptographic quality of many-body logic functions, cryptographic quality indicators are developed to compare the cryptographic quality of many-body logic functions with an arbitrary value of their length and the basis of representation, namely relative algebraic degree of nonlinearity, relative distance of nonlinearity, maximum and integral deviation from SAC, maximum and integral deviation from the criterion of correlation independence of output of function of many-body logic from its input variables. Step 4. The cryptographic quality of constructions of non-cryptographic algorithms is investigated and compared, which allow to make recommendations for their further improvement using the mathematical apparatus of functions of many-body logic. Step 5. Methods for the synthesis of large sets of highly nonlinear functions of many-body logic, namely band sequences, perfect arrays of many-body logic, are created. Methods for the synthesis of S-boxes that are highly nonlinear or have the maximum possible nonlinearity in the sense of component functions of many-body logic have been developed. Step 6. Methods for synthesis of cryptographic constructions on the basis of functions of many-body logic corresponding to the strict avalanche criterion, and also functions of many-body logic corresponding to the criterion of independence of an output from input variables are developed. Method for the synthesis of S-boxes that satisfy the strict avalanche criterion of many-body logic functions and the criterion of independence of the output from the input variables of component functions of many-body logic are presented. Step 7. The concept of variable fragmentation of blocks is developed that allows to make the best use of advantages of the developed high-quality cryptographic primitives on the basis of functions of many-body logic. Based on the developed concept of variable block fragmentation, a cryptographic algorithm based on many-body logic functions is presented, the structural elements of which are optimal from the point of view of the cryptographic quality criteria of many-body logic functions. Let us to summarize the main results of our research. At the moment, there is an objective contradiction between the developed methods of attacks on cryptographic algorithms, the possible representation of their structures by functions of many-body logic, while simultaneously developing promising methods of attacks using quantum computers and the actual absence of a comprehensive mathematical apparatus designed to research the cryptographic quality of component functions of many-body logic and methods for synthesizing cryptographic structures that are high quality in terms of many-body logic functions. The solution to this contradiction is a prerequisite for creating a methodology for estimation and increasing cryptographic strengths based on the functions of many-body logic. A methodology for estimation and increasing cryptographic strengths based on the many-body logic functions is presented, consisting of the cryptographic quality criteria, indicators, and methods for their calculation. The developed methodology makes it possible to estimate and compare the cryptographic quality of existing cryptographic algorithms, as well as to develop new ones that will be of high quality both in terms of Boolean functions and in terms of functions of many-body logic. Based on the research results, 57 publications were made, of which 18 publications are included in the scientometric databases Scopus and/or Web of Science. Dear colleagues, thank you very much for your attention and watching of this video.